When adding and subtracting polynomials, you combine like terms. Remember, if there's a subtraction sign before the parentheses, you need to distribute the negative. It's important to remember that you can only combine the terms that have the same variable and exponent. So same variable and exponent, because they have to look exactly alike. Do you remember that? Same variable, same exponent. I have no clue why my E's will not work today. Okay. Now this section here should be pretty straightforward and easy for you, okay? So we have, yes? It's the thing after it, okay? All right, so here we have 4x squared and 2x, so that becomes 6x squared. Remember, you add the numbers, keep the term. The exponents only change when you multiply and divide. Okay, and then you have plus x and plus 3, so you get plus 4x and then plus 8. Do you remember that? Okay, so let's look at number 3 here. I just put extra in there in case we got to distribute first. So when you distribute, the exponents will
stay the same.
Distribute, they will change because you were doing what when you distribute? Multiply. 3 times 4 is 12, and then I have 1a and 2a, so I have 3a's, right?
How do you get 3a if the a is 1?
1 plus 2 is 3. Remember, when you multiply, you add exponents.
Oh, yeah.
3 times 3 is 9, and then a to the second. 3 times 1 is 3a. Does everybody understand? Add exponents. Okay, then we're going to distribute this 7. We get 7a minus 35. And this may be easy for a lot of you because, like I said, you did this in middle school, okay? And then you did it again in algebra, and then you did it again in algebra 2. But I'm just trying to remind you of these rules in case you've forgotten them. Okay, so this one here does not have a like term, so we bring it down. 9a squared doesn't have one. We combine 3 plus 7, and we get 10a minus 35. We good there? Is anybody like completely lost? Okay, I'm trying to me this should be something you know how to do, but I don't want to assume that, okay? So I'm trying to teach it just like it's brand new. And I know some of you are sitting here going, I wish you would just quickly get done so I can do my homework. But some of you are like, I'm really confused, Miss Liz. All right, in this one we have a subtraction sign. So we're going to bring the first one down. And then we're going to distribute that negative, so everything after the sign will change. Does that make sense? And now we're ready to combine like terms. 3x squared cubed minus x cubed is 2x cubed. And then negative x squared minus 5x squared is negative 6x squared. 4x doesn't have a friend, so we bring him down. Plus 8 and plus 7 is plus 15. Does that make sense? Okay, you good? All right, so you do number 7, and then we will check it and move on to multiplying if you're good. Don't just sit there if you're not good, though. Raise your hand if you're struggling. Everybody good? Okay. It may help you to write in columns. So like I put the 3p plus 1, and then I distributed and got 6p minus 48, and I lined up my like terms. So if you're having trouble with the long one, you can write them in columns, and then negative 3. So 3 plus 6 is 9, minus 3 is 6, 1 negative 47, and 6 is negative 53. Good? Everybody good there? What are you not good about? Did you get positive 6 minus 48?
I got 6p minus 48.
Did you get negative 3p minus 6?
No.
Do you see how I got that?
Oh, I didn't multiply that. I got
Okay.
negative 3p plus 2.
Okay, does that make sense?
No.
Don't forget to distribute that to both terms. That is a common mistake. Any questions there? Okay, so let's look at the last part, and that is multiplying.
What was it, like 6p?
Oh, sorry. It was 6p minus 53. Okay, so you can use the distributive property, or if you're one of those people who lose a lot of negatives, you constantly make simple mistakes, then you may want to use the box method. Okay, I'm going to show you both in case you haven't seen it. At this point, you should be able to use the distributive property for all of them, but sometimes that's just not where we get to, and we want to use the box. And I like the box personally. I even use it myself just because it makes everything line up nice and neat. So if you remember here, when you have x plus 3 times x minus 7, a lot of you use the FOIL method, right? You distribute the first to the outer, the inner, the last. You can also do this box method. So let me show you this in case, if you are a person who makes a lot of mistakes, this box method helps with that. So you draw, since there's 2 by 2, you draw a 2 by 2 box. Has anybody ever seen this?
Yes.
Yes. Okay, so you get x plus 3 up here, or you could have put x minus 7. It does not matter which order you put them in. And then x minus 7 here. This just organizes your data and helps you not lose things and not make mistakes. X times x is x squared. X times 3 is 3x. Negative 7 times x is negative 7x. And negative 7 times 3 is negative 21. 90% of the time, your like terms will be across from each other. So that leaves me x squared from this first box. Negative 7 plus 3 is negative 4x. And then I bring down the negative 21. Now, at this point, you should actually be able to look at this problem and just go, oh, x squared minus 7 plus 3 is negative 4 minus 21. But I've seen some of your tests, so I know that's not always the case. I'm trying to be nice there. But so, if you can't do that, please make sure you show your work. But you should be able to do that one kind of in your head. Okay, so when you get here and you have different variables and everything, so I'm going to do one using the FOIL. If you like the box, just do the box and ignore me. 4 times 5 is 20, and then we add, so that would be x to the 4th. Yes? And then 4 times negative 8 is negative 32, x squared y, plus 5x squared y, minus 8y squared. Does everybody understand how I got those numbers? And then my like terms are here in the middle. Just be careful and make sure you add your exponents there. Negative 32 plus 5 is negative 27 x squared y. And then when you combine like terms, your exponents don't change. So don't forget when they change and when they don't change. Okay, any questions there? Yes. Yes, I'm going to. Do anybody need me to do another one like 3 and 4? Oh, so sorry.
I'm just going to write the answer.
Do you need me to explain something, Reed?
No, I'm just not going to do it when you're done.
Okay.
I don't want to see it.
That's okay. I don't mind helping. All right, anybody need me to do 3 and 4 since they're like 1 and 2? I didn't. Okay. Let me discuss 5, then we're going to hop to 6, okay? What does this mean? Right. So this is what this means. This does not mean you're going to distribute and get 49p squared plus 4. That is not what that means. So don't do that or I'm going to be mad. Okay? All right, so let's look at this one. This one has 2 terms and 3 terms. Sometimes you'll have 3 by 3s, 4 by 4s. I mean, you can multiply a polynomial times anything. So in this case, if I were to do the box, and you don't have to, I can do the distributive property in a minute also, but I would have a 2 by 3 box because there's 2 terms here and 3 terms there. Does that make sense? And then I get 2x minus 5 and x squared minus 5x plus 4. Does that make sense? So you get 2x to the third minus 10x plus squared 8x. Good? Questions? And then negative 5x squared plus 25x minus 20. Anybody have a question? Okay, notice the like terms are across from each other again. We write down the first one because it doesn't have a like term. Negative 5 and negative 10 is negative 15x squared. Now, I will tell you a lot of times students will make that x to the 4th because you just got through multiplying and now you're going to adding and you have to remember not to change the variable. And then that would give me 33x minus 20.